Welcome to week 3 of Fireside Chats with Mr. Klepfer. As you can see, after catching a little flack from everybody last week about having a fake fire, I decided this week I was going to do something a little different and have a real fire here in my classroom. So there it is. So in week 3, we're going to continue sort of where we left off from last week. Last week we started talking about science and what it is. And you did a little research on a variety of different scientists and learned kind of their contributions to society. This week, we're going to focus more on how scientists do science, the process that they go through in order to have these great achievements that they've had. So we're going to take a look at that process a little bit. This week, you're going to do some activities that allow you to go through that process to see how an actual scientist would do it. So let me start by showing you what the process. So what you see on the screen right now is a diagram of what we call the scientific method. The scientific method can go by a variety of different names: scientific inquiry, a scientific process. It can go by the engineering process, but they're all basically the same thing. They all go through this process that you see on the screen. Now, right now, it can look pretty complex because we have arrows going all over the place, but it's really something that all of us do on a daily basis. Okay, because science is a way to solve problems, and we all have problems that we need to solve regularly. And this just lays out the plan for how that is done. So while you don't really see a starting spot, really the starting spot is right here at making observations. There are things that happen in the world, things you observe with your 5 senses, and that leads you to ask questions. Why do those things happen that way? What causes something to happen? Why would somebody do something like that? All those things, all those questions that pop into your head that come from observations, that is really the basis for how science works or why we need science to do anything. So you start with observations and then you move to asking a question. That question needs to be something that can be solved using science, which means it can't be an opinion-based question. It's got to be a question that's based on factual information. Okay, so asking a question like, let's see, why is my favorite color blue? Okay, well, that's not really going to be something that is based in fact. It's going to be something that's based in an opinion. Okay, so you need to ask something that's based in fact, something that you can back up using data. So once you ask that question, the next step is to formulate a hypothesis. A hypothesis is just an answer to a scientific question. Now, most of you may have learned that it's an educated guess, and that's fine for an elementary school. But now that we're in the high school, you need to understand that it's really not a guess. Okay, hypothesis is an answer to a question, and you're basing that answer on observations that you've already made. You're not really just guessing. Guessing always implies to me that you're just pulling something out of thin air, and that's really not what you're doing with a hypothesis. You're taking information that you already know, and you're turning that into what you think is the answer to your scientific question. Okay, so we need to stop looking at it as sort of a guess, and we need to start looking at it as an answer to a question that we think is possible based on what we already know. Okay, so once you formulate your hypothesis, you're going to make some more observations possibly, or you're going to go down here and test your hypothesis. It really depends on the question you asked. But once you're testing your hypothesis, that's just a fancy way of saying we're going to conduct our experiment. Okay, we're going to set up some sort of experiment that's going to help us collect data so that we can show whether or not our hypothesis was correct or not. Okay, so you conduct your experiment. After you do that, you're going to analyze your results. Okay, Analyzing results just means you're going to look at the data and you're going to try to determine if that data or what that data means. Okay. You're going to interpret it. Okay. Like it's a different language, and you're going to tell us what that data is actually showing you. After you analyze your data, you're going to draw conclusions. You're going to take that data, you're going to determine what it means, and you're going to figure out if that supports your hypothesis. So in other words, does it say your hypothesis is correct? Or is it going to say that your hypothesis is incorrect? Does it not support your hypothesis? Okay, and either way is okay, because as long as we're learning, being right in your hypothesis is really not that important. It just kind of gives you something to go by. I often find that we actually learn more if our hypothesis is incorrect, because we usually go back and start the process over again, which means we're going to learn more. If our hypothesis is correct, sometimes we stop right there. We don't really dig any deeper. So being wrong is actually a good thing. I often tell kids that we learn more from being wrong than we learn more from being right. So being wrong in your hypothesis and having that no show up is sometimes a good thing. If your hypothesis is no, like if it doesn't support your hypothesis, your data doesn't support it, usually what we do is we go back and we formulate a new hypothesis and we start the whole process over again. Okay, we try something a little different. If your hypothesis is yes, then you're going to communicate your results. You're going to tell people about it. You're going to explain to them why your hypothesis is correct, and you're going to show them your data and what it all means. You're going to communicate your results to somebody. After you communicate your results, sometimes you'll test your hypothesis again. Other people will test your hypothesis to kind of make sure that what you did was correct, and they'll go through the process to kind of back you up. Sometimes that leads the whole way back up, and there's no arrow for this, but sometimes it leads you the whole way back up to asking more questions, different questions that are related to your hypothesis or related to the first question that you didn't really have time to answer. Okay. So this process is really never ending. It's just going to keep going on and on and on forever. And that's part of the beauty of science, is that it is never ending. We always are going to have problems. We're always going to have things that we need to solve. We're never going to know everything. Okay. There's always going to be more questions out there that we want to try to answer. And this diagram that you see on your screen is just a good base. Okay. The order sometimes changes, the steps sometimes change, but it provides a good base for problem solving, which is what science is all about. So after looking at the entire scientific process, I hope that you see that, number one, it's pretty complex. But even though it's complex, it's something that we all can do, right? We all experience problems in our lives on a daily basis. Science is a way to answer those problems. That's what we learn here in class. We learn how to solve problems. And that step-by-step process that I just showed you is the way to solve those problems, or it's a way to solve those problems. And really, anytime you have a problem, you go through those steps. You may not think you're going through those steps. You may not write anything down. You may not formulate like a scientific hypothesis. But really, anytime you solve a problem, you are using those steps, whether you know it or not. And as we go through the activities this week, I'm hoping that you see that you are using those things. I look forward to seeing what you come up with this week. And next week, we'll have another chat. Thanks for joining.